Hello Internet, my name is Quinn and this is Blondihacks. Today I'm going to build a dovetail slide. Now this is a great basis for lots of tools and fixtures at somewhat more of an advanced level in your hobby machine shop. So for me it was an excuse to build one of those, learn how to do it, but it's also going to be used as kind of the overkill base for a corner and end rounding fixture for my belt sander. So if any of that interests you, stay tuned and let's go. Here is the dovetail slide that I'm going to build today. It happens to have a brass thumb wheel on the end for use on my belt sanding fixture that I'm going to show you at the end, based on a 1/4-20 piece of threaded rod as the lead screw, but we're going to make everything else. This is a bog standard dovetail slide, so if you want to make one for your own shop for virtually any purpose, if you're building your own lathe or your own fixture of some sort, you should be able to follow this. I'll be using this as a fixture for rounding the corners and ends of very small parts. Longtime viewers will know I built a fixture for doing similar work on the rotary table on the milling machine. However, that's not well suited to very, very small parts, which I'm doing a lot of these days. And the idea for doing this on the belt sander came from a fellow named Kim over on the Model Engine Maker forum. So I'm taking his idea and just kind of leveling it up a little bit with this fancy dovetail slide. I modeled this in CAD and went ahead and made myself some drawings for this, which are all available on my Patreon if you're interested. And it's all designed around this piece of aluminum scrap that I happen to have on hand. The dimensions for all this don't matter a whole lot. This piece of scrap is just what I had, so I designed the slide around it. I'm going to start by squaring up the two pieces of aluminum for the upper and lower halves of the dovetail slide. I'll start with the short edge, since this is an easy cut. I'm using the traditional method of squaring up stock, which is useful on smaller milling machines and also in a case like this where your stock is very close to the final dimensions that you want. You just need everything to be square. So you create one reference surface, whatever cut is the easiest, usually opposite whatever side of the part is already the squarest. In this case there was a factory cut on the bottom edge, so I'm using that as a starting reference, then creating the first true reference by milling this edge. Then I put that edge against the fixed jaw of the vise, and I put a piece of copper wire or a round bar or something along those lines to keep the movable jaw from influencing the orientation of the part, since that side is unmachined. Then I tap that in, and I machine this face to be square to the first reference face that we created. For this I'm using my larger Shrum Solutions Tri-Fly cutter. It's kind of a small face mill for hobby mills. It's a 3-insert face mill, really handy for this sort of job, but not so big that it would overwhelm the hobby milling machine like most face mills would. Finish on that cutter looks really nice. Let's see if it passes the Swarfy test. Swarfy does not play well with other ducks, so if he attempts to murder the reflection, then you know it's a good surface finish. Are you happy now, Swarfy? You're kind of a jerk, you know that? Next, that square corner that we created with those two faces goes back and down in the vise, and we mill the opposite side to square it up and also bring this down to dimension. And rinse repeat on the remaining sides. If you want a complete treatise on squaring up stock, go check out my Mill Skills playlist. I devoted an entire video to this topic. Here are the two pieces squared up for the upper and lower slides. Now we just need to make them into dovetails. I'm going to start with the lower dovetail slide. It's the most complex piece on the whole assembly. I'm going to center it up in the vise. We can do a lot of operations, almost all of them from this one setup, so it should be pretty efficient. With everything centered up with the edge finder now, I'm going to start by creating the dovetail itself. So using a large end mill, I'm going to side mill my way into the outer dimensions of the dovetail, so the outer peaks, which are marked in the drawing. That makes it easier to cut the dovetails because we have the outer surface of the dovetail already established, the outer edge of it, if you will. We only have to cut in from here. Plus, an end mill is going to be able to remove material a lot easier than the exotic dovetail cutter that we'll be using to create those angles. So this is roughing in the dovetail, if you like. I've chosen aluminum for this dovetail slide instead of something more traditional like cast iron. The reason being twofold. First, my belt sander table is really flimsy and is not going to be able to hold a lot of weight. And second, this is my first time ever making a dovetail slide, and aluminum is easy mode for something exotic like a dovetail cutter. Here's the star of the show. This is a 60-degree dovetail cutter. This was donated to the channel many years ago, and it's used and in unknown condition. But it feels sharp to the touch, so we'll see how we get along with it. This is just aluminum, which is the easiest case for dovetail cutting, so that'll help. Step 1 then is to get it aligned with the surface that we roughed in. I don't want it to cut that lower surface. I want the cutter to just be on that surface. So I lower it down using a feeler gauge so I don't mar up the surface like you would with the touch-off. And then I zero the DRO there and then lower it by the thickness of that feeler gauge. And now I know my cutter is going to be right on that surface without actually cutting it. And from here I can move inward to cut the dovetail. You could also leave a few thousandths shy on the rough-in cut that you did, but then you're asking the dovetail cutter to do a lot more work. And this is an aggressive form cutter, especially for a hobby mill, so the less work you can ask it to do, the better. I'm taking very, very light cuts on the first couple of passes because, again, I've never used a dovetail cutter and I have no idea how my milling machine is going to respond to it. I also don't know anything about what a good feeder speed should be for a cutter like this, so just taking my time, start with light cuts and then build up a little bit on each pass. It also gives you time to experiment with speeds and feeds and get the feel for when the cutter seems happy. A gotcha that you got to watch for with form cutters like this is because of the angle of the cut, the deeper in you go, the heavier the cut gets. That means you don't want to move in the same Y delta each time. If you do that, the cut is getting heavier and heavier each time by the cosine of the angle of the cutter. What you actually want to do in order to maintain a constant cutter load is take lighter and lighter cuts as you go in. That seemed to go well though. I was able to ease my way in on both sides of that cut, essentially until the dovetail cutter met the existing edge that I'd created with the regular end mill, and that looks like a dovetail. Well, so far so good. Next is a slot down the middle of the part for the lead screw nut to slide up and down in. This is pretty thick material, even though it's just aluminum. It wouldn't be too difficult to cut it with an end mill, but I think I can save myself a lot of time and cutter wear by chain drilling out the bulk of this material. I started by center drilling each drill position using the DRO, and then I go straight to the drill size. No pilot drilling or anything needed here. The goal is bulk material removal. We don't care about accuracy or precision or anything like that. The real trick with chain drilling is to get just the right overlap on the holes. Typically about 1/4 of the diameter is the most you can get away with. This is 1/3 that I'm doing here, and this is really pushing it. The drill is definitely rattling around in those holes. It wants to cut into the hole adjacent to it. And, well, it's not very happy. I made it do it, but really 1/4 is about as much overlap as you should do. I basically got away with that, but you'll see later that there was some trouble caused by my overly greedy overlap of these holes. Now to clean up the edges, I plunge down with an end mill at the edge where the slot needs to be, minus a few thousandths for a finishing cut. And I'm going to do a couple of roughing passes all the way around the slot with an end mill to rough in the corner radii and clean up the detritus from the drilling. After 2 laps around of roughing in, then I do a nice light finishing cut all the way down. Of course, this end mill is going to leave a corner radius at the edges of my slot, but I've accounted for that in the design, and I've chosen this end mill to match the radius that the design expects. I don't know if it shows up on camera, but if you look closely in this corner, there's a little bit of a dimple still yet from one of my chain drilling operations. That's where I got too aggressive with my overlap, which caused the drill to deflect more than the margin I had allowed myself on the drill size versus the final slot size. So I should have chosen slightly smaller drills, or I should have overlapped the drills less. Next up are the holes on the ends of this slot for the lead screw. There's a bearing at one end and the hand crank thingamajig at the other end. For this, I'm going to set it up vertically on my angle plate just outside the vise here. I've got just enough room to do this. So I'll clamp it up like so, and then I'm going to indicate it in and get it perfectly vertical in this dimension. The angle plate will hold it vertical on the x-axis, but on the y-axis I need to tap it in. The lead screw is perfectly centered on both axes in the final part, so this is a simple matter of edge finding on x and y to get myself centered up. Next I will center drill and drill through. I'm going to do a pilot drill and then the final drill size. The dimension that I need does not match a reamer that I have, so I'm going to finish this hole with a drill. To that end, I'm drilling carefully with a pilot drill and a center drill, as you've seen, going up in a couple of stages. And then the piece that goes in here, I'm going to cut to fit. So if this drill cuts a little oversized, as drills sometimes do, it'll be okay because I'm going to make the mating part to fit. I'll check with a gauge pin to see exactly where I landed. And well, the good news is actually that drill appears to have cut exactly on size. That was a brand new drill with a factory grind on it. And as I say, I was cutting carefully, and this is aluminum, so all of that helps the drill cut on size. But it was perfect this time, but most of the time it won't be with a drill, so this order of operations is still always a good idea. To that end, I'm going to leave that right there now, and I'm going to go over and cut the mating part on the lathe. This is a little bearing. It's just a simple bushing with a blind hole in it that's going to run in the opposite bore on the other end of the lead screw's crank handle knobby thing. That's a technical term. Let's see how I did. Survey says, oh, look at that. Perfect. That slides in there easily, and that's a nice, easy spinning, running fit, whatever you want to call it. It's not too tight, and it's not slopping around, so that should be perfect. By leaving it set up in the mill like that while I did that, I could, I don't know, make additional cuts if I needed it to be smaller, or I could make reverse cuts if it was too big, you know, standard stuff. Now, in a perfect world, the matching bore at the other end of this part would have been done in the same setup, but I don't have a drill anywhere close to long enough, nor do I have enough travel on my mill vertically to do a single cut all the way through this part. So I flipped the part over, dialed it in again, and I'm basically relying on the quality of my dialing in to get the bores lined up on either end. That should be sufficient for this. This is a piece of threaded rod. This isn't something like a crankshaft where it has to be absolutely perfect in alignment end to end. Well, that's it for the lower dovetail slide. That is looking pretty good. The rest of the pieces should be easier, but we still have a lot of pieces to make, so let's get started. On now to the upper slide. This is done very similarly. I'm going to start by roughing in the innermost dimensions of the dovetail. This is a female dovetail, so I'm carving out the center of the piece. I'm using adjustable parallels to keep track of my progress as I cut this slot. It's an easy way to get a pretty accurate measurement of an inside dimension like this. I nailed the dimension, however, I did not nail the position. Unfortunately, I forgot that the female dovetail has to be off-center because you have to have room for the gib on one side. So I've cut it the correct dimension, but in the wrong position. Now, we can compensate for this error later. It's not going to be worth remaking this part, so stay tuned for how we do that. But now I'm going to cut the dovetails. You might notice this is a brand new dovetail cutter. That one I used for the male dovetail had exactly 2 dovetails left in it. On the final cut of the second dovetail, it was starting to grind and it was dull. So luckily I got away with that, and I bought a new dovetail cutter for this piece. I've also figured out a new trick for getting the dimensions just right. I've blued up the square surfaces with Sharpie, and this gives you an easy way to know when your depth is correct. You mill sideways with the dovetail cutter until you've got just a wisp of blue showing on the peak. This is a trick that I learned from instructional videos on the D-bit grinder. You use the same trick when grinding clearances on tool bits to know when you've got the clearance angle meeting up with your cutting edge without removing your cutting edge. Same trick. Works really well here as well. I'm going to do some deburring in situ and do a test fit with the other dovetail, and let's see how that works. Ooh, that looks really good. Very pleased with that. I mean, the dovetail cutter does all the work. All I did was push the buttons and watch the machine, but that still came out really nice. Got a nice space there for the gib, and everything looks good. You can see the misalignment of the 2 slides laterally, and that misalignment is half the thickness of the gib because of my centering the female slide. As I said, though, we'll correct that later. Now it's time to make the gib, and I want to know exactly what this space is. Rather than just making the gib to the drawing and trusting that I did everything else perfectly, I'm going to use gauge pins and see what the size of this slot is. The nice thing about doing this with gauge pins is that I can actually put the entire pin in there, and it acts as a kind of a temporary gib, and I can make sure that the feel of the slide is correct. And then I know for sure what the dimension of that gib should be. I'm going to make this piece from brass. Gibs are pretty tricky things, but this is the easiest form of gib. It's straight. Tapered gibs can be quite sophisticated things to cut. This is a straight gib. It just has to have that funky parallelogram shape to it so that it fits in the dovetail slide. I'm going to start by rough cutting it well over size on the bandsaw, and then I'm going to set it up to mill it using my sheet metal clamping bars. These are pieces that I came up with for clamping long, thin pieces just like this on other projects. It's going to be great here as well. Allows me to hold a piece like this very securely. There's a thin parallel underneath it for a square reference, and there's little pieces of scrap at the bottom edges of these clamping bars that are the same thickness as what I'm milling to create even square clamping pressure. With both sides milled straight and parallel, it's still oversized at this point. You'll see why later. But now I'm going to move over to the angle table because I need to create one of the bevels. To make my life easier, I'm going to bolt a fence onto my little angle table, and I'll indicate this in with a little tapping to get the fence straight. I've already indicated the table in straight, so I know it is, but the fence, of course, has to be indicated in separately, as does anything that you bolt to the table, unless you can put it up against the fence. That fence is optional. It's really just to make sure that the clamping bars have something nice to sit against that's going to make me feel better that I'm going to get nice, even, straight clamping pressure without the bars themselves being all cattywampus. I'm not actually using the clamping bars or that fence as a reference for anything though. Again, it's just to make sure my setup is clean. I am actually still going to have to indicate in the piece to make sure that my cut is parallel, because there's no parallel inside the clamping bars like there was when this was set up in the vise. So the piece was indicated in. Now I can set the angle to 60 degrees to create the proper parallelogram angle on the top edge of my gib. You might notice there's holes drilled in the ends of the gib as well. This material is overly long, and I thought I might be able to use those holes for fixturing at various points, so I put them in there just in case. I didn't end up using them, but I will take advantage of the fact that the piece is overly long in a moment. That setup worked really well. Now you can see the little parallelogram cut on one edge. Now, of course, we have to make the matching angle cut on the other edge. However, I'm going to cheat. I'm going to be able to get the angle correct and the overall width of the gib correct in one go by cheating and using the actual dovetail slide as the fixture to hold the part for the second cut. So I'm going to insert the piece that we've cut in there. You can see that it's still over height. All I need to do for this trick is set the dovetail up in the vise, and I can put the gib up against one of the dovetails. And I'm going to hold it in place now with a piece of sacrificial scrap. That's just a piece of square bar I found in the bin, happened to be the right length. And I'll clamp that square bar in place, which is going to clamp the gib up against the dovetail and keep it from moving. I'll tap that clamping bar in just to make sure that it's nice and secure. And I did find that it needed an additional C-clamp in the middle to hold it tight. Then all I do is mill this side of the gib down as close as I dare to the surface of the dovetail. I don't want to cut into my dovetail, of course, so I'm doing this very carefully, going down a little bit at a time until I get that depth established. And of course, I can't do the whole cut in one go because of the C-clamp, but I can do most of it, then flip the clamp around to the other side and finish the cut. That will need a little bit of hand fitting because by definition it's going to be a little bit oversized unless I had cut into the aluminum of the dovetail, which of course I don't want to do. So by cutting to just above the surface, the gib will be very close, but will need a little bit of filing. The next step is to thin out the gib because I'm a moron and didn't design the gib to be the same thickness as some material that I had on hand. I made it a little bit thinner. Luckily I had those sections on the ends that are overly long, so I was able to use those to clamp it down to my fixture plate and thin that piece out a little bit. There's the final piece. You can see that it's thinned out and the angles are cut on it, except for the waste material at the end that was used for fixturing, which I've now cut off, and now I'm doing that hand fitting that I mentioned was going to be required. I just got to file a couple of thousandths off one of the beveled edges so that it sits just below the dovetail slides at the top and bottom and doesn't rub on either of the two halves of the slide. That's a little too tight there yet, so I did a little bit more work on that. I knew it was a good fit when I could push the gib in from the end with minimal resistance, but it's not sloppy. It's not going to fall through that hole, but I can easily push it in from the end all the way down. Then I know I've got a nice sliding fit. That slides nicely now, but of course there's nothing holding the gib in place yet, so it's moving around a little bit. But we'll deal with that in a moment. It certainly looks the part though. It's looking very dovetail gibby in there. Now is a good time to deal with that misalignment due to my centered dovetail. What I'm going to do is mill the whole assembly narrower But you got to do this in a particular way because the goal is not to make the sides flush. The goal is to end up with the lead screw still centered and the sides flush. So what I did is I milled the amount required off the lower dovetail to be flush with the upper dovetail. Then I milled the same amount off the other side of the lower dovetail, which means I'm milling more off of this side of the upper dovetail than I did on the other side. I hope that makes sense. You have to mill more off of one side in order for the lead screw to remain centered in the piece that I'm using as the reference for the milling. After that, while I've got it in this setup, it's a good time to drill and tap the gib adjustment screws. These screws hold the gib in place because there's little dimples in the gib, and they also let you set the tension of the gib to make sure it's a nice sliding fit. Next part I'm going to make is the cranky knobby thing. That's a technical term once again. It's in Machinery's Handbook in the back somewhere. Look it up if you want. You can see a diagram in the upper right of what this is going to look like. It's a very straightforward part. I'm just going to zip through this because you don't need to see me turn a bunch of shoulders and do some drilling and tapping. Nothing too exciting here. And since someone always asks, that tool bit holder that you see is a tangential or diamond tool holder. That one happens to be from Eccentric Engineering. Hashtag not sponsored, but they're great tools. Go buy one if you like. The knob is attached to the lead screw in a very low budget way. I drill and tap the end of it for the lead screw, and it's simply going to be Loctited on. And finally, the knob gets knurled. This knurling tool is one that I built from a kit. I've got a series of videos on this if you're interested. Go check out my playlists for that. It's a very nice knurling tool. However, nice tools cannot compensate for lack of skill, and I am not a good knurler, so once again, this knurl is going to end up adequate, and don't look too closely at it. Of course, the real secret to knurling is to chamfer both sides of it when you're done. That has an amazing ability to make the crappiest of knurls look 78% less crappy. Next up is the lead screw nut. I'm going to skip through this as well. It's not very exciting. It's basically a cube with a large thread down the long side. Wait, is there a long side if it's a cube? All right, it's not quite a cube. It's cube-ish. There's a thread down the long side for the lead screw. That gets nice chamfers on both ends. And then there's a much smaller thread on the short side that attaches the lead screw nut to the upper slide. I also took the time to round over all the corners of this with a file to make sure that this nut can slide nicely through the slot. If it ever gets, grinding grit or something in there, little curves will help ease it through life. I need a way to attach this whole fixture to my belt sander, so I'm measuring the slot with an adjustable parallel, and I'm going to mill a little key to fit in that slot. For this key, I grabbed a scrap of aluminum, squared it up, and drilled and countersunk some holes in it to attach this key to the underside of the lower dovetail. And then there's also some threaded holes in it that allow me to bolt this key to the belt sander table. This fixture might be okay if it was just sitting on the belt sander table, but I think it'll be advantageous to have it bolted down because I'm going to need two hands to operate the fixture, as you'll see in the end. And not having the fixture want to slide around on its own seems advantageous. We'll see. To mark the belt sander table for drilling, I'm using transfer screws. These look like set screws, but they have a little hardened point on them. And they come in a little tube. The tube is the tool that you see me using to install them. You thread them into an existing hole so that the little point is just proud of the surface. And you can buy them in all different thread sizes. And then you set the thing where you want. I'm centering it on the belt, not on the table. And then you just give it a little tappy tap tap, and that makes an impression in the other piece for wherever the center of those threaded holes is. They're really handy little things, and then I can deepen those with a bigger center punch. Now that's ready to drill. I'm going to drill these out with a step bit because this is a chintzy sheet metal table, and step bits are awesome in sheet metal, especially when the exact diameter of the hole doesn't matter a whole lot. Step bits are not as accurate as other methods of hole making. I had to call a quick audible at this point. I realized my design lacked any way to retain the lead screw in the assembly, so I need some sort of a collar on the other side of the knob. For that, I milled up a little brass ring on the lathe, filed a flat spot on the lead screw, and there's a little set screw on that collar that's going to lock into that flat spot, and that's going to retain the entire crank assembly in the dovetail. All right, let's do some assembly. I've got the knob Loctited on the end of the threaded rod, and I feed in the lead screw nut. And then I Loctite the bearing on the other end as well. If I ever need to disassemble this, of course, a little bit of heat will break the Loctite, so this is not the commitment that it might seem. A little bit of oil for final assembly. A little bearing goes in there at the other end. tighten down the set screw on that little locking collar, and I think we are in business. That seems to be moving just fine. I'll get the upper slide installed next. Again, the gib is already in there and it's being held in place by little dimples that register with those gib adjuster screws. That slides on there, and then one more little screw attaches the upper slide to the lead screw nut. Finally, my key attaches to the underside. You can see the threaded holes outboard of that, which are what bolt this assembly to the belt sander table. I think we might be ready to give this thing a little test drive. Looking pretty good. I gave the gibs a bit of a preliminary adjustment. That goes on the belt sander table like so. And I should be able to crank the slide in and out for adjusting my depth of cut on the belt sander. That is looking pretty good. One thing you might notice is that the cranking direction is reversed from what you might be used to on the cross slide of a lathe, because of course lathe cross slides have left-hand threads in them, and I've used a regular right-hand thread. But you get used to that. Alright, let's give this a real-world test. This is my intended use case for this particular dovetail slide. I'm drilling a hole close to the front edge that holds a pin that I've turned on the lathe, which is the exact diameter in the center of a part that I want to round to the end of. Here's the part that I want to round. You can see that that's going to allow me to rotate that part around that pin right up close to the belt, and then the slide will allow me to adjust my depth of cut as I feed in to round this corner. The pin is off to one side to leave myself room for other pin sizes in the future. The cool thing about this fixture is that different radii can be done with the same pin if the hole is the correct size, just by adjusting the dovetail slide. So I'll get a lot more use out of this than some other types of end rounding fixtures where you have to have a separate setup for every combination of radius and center pin. And away we go. You can see this is a two-handed operation, hence my desire to bolt it to the table. I swing the part around the pin and crank in the dovetail slide a little bit as I go. And I just gradually work it in until the curve that's created is a full 180 degrees, or 90 degrees if you're going for that. Very, very simple. I gotta say, that worked really, really well. It's certainly massive overkill for this job, but I gotta say it works incredibly well, and it's very pleasing to use. This is the other end of that same part, and I'm getting a little better at using the tool with some practice, and this one went even better. One obvious avenue for improvement already is that I may want to slot the holes in the table so I can move the fixture back and forth a bit, because you can see how this is going to wear out one strip on that belt pretty quickly. For a few parts it's fine, the belt survives, but if you were going to do 20 parts of the same dimensions that are on the same spot on the belt, you would wear out that belt before you were done probably. So the ability to move the part around on different areas of the belt is probably a good idea. But I gotta say, as a proof of concept, that worked super well. And this is designed for really small parts. For larger parts, I have my corner rounding fixture on my rotary table that I use. You've seen videos on that. So this is really for the really small stuff where the rotary table isn't practical. Well, there it is, one dovetail slide. This is going to be what I call my belt rounder, my end and corner rounding fixture for the belt sander. But as I said at the top of the show, this is just a bog standard dovetail slide. You can make all sorts of fixtures and machine tools yourself this way if you like. I hope there was something in here that was useful to you. Thank you very much for watching, and thanks especially to my patrons who make all of this possible every single week. You folks are the best, and I will see you next time.